Hi, I'm Nishant, and today I will explain the various details I have gathered based on the problem statement that is given. So, here we need to predict the net hourly electrical energy output in megawatts based on the various environment variables that are given surrounding the power plant. So, we can see that we are given the temperature, ambient pressure, relative humidity, and exhaust vacuum. And we are trying to predict a continuous variable as an output here. So, this is a regression problem. Now, the y variable that we want to predict is the net hourly electrical energy output in megawatts. Now, regression problems can be solved using various regression algorithms such as linear, lasso, ridge regression, and some of the other methods includes like KNN, regressor, and there are various other methods where we can use for the regression problems. Now, regression accuracy metrics are basically the MSC, MAP, MAE, RMSC, R square, and that we can use to compare various models. And we would like to minimize the root mean squared error and maximize the R square for each of our models. Now I'll explain the code that I have written. So I have imported all the required libraries here, and so first I have read the data using pandas read underscore CSV, and this is the data that we can see. I have described the data in order to understand what is the mean temperature, mean vacuum, standard deviation, minimum, maximum values, the percentile values, the counts in the each of the columns, etc. I also checked in terms of if there is any null values in the data, and I also checked the scatter plots using pair plot for various columns that we have, and we can observe that here we can see that the V vacuum variable and the AT temperature variable are almost like positively correlated, and the AT variable and the final PE variable, which is the Y variable, are inversely correlated. We can also look at the histograms that are plotted here. We can see there are two main peaks which are observed here, and there are some peaks here for this uh, V variable, and we have almost like a normally distributed data for AP variable. We have skewed data here, and we have some like again two peaks here for the PE variable. Now, first I will split the test and the given data into train and test. And P is our Y variable, and rest of the columns are X variables. These are our features. I have used training size of 80%, and since all the values are in numerical nature, so I have standardized the data because since everything has its own scale, we can see that the temperature is between 1.8 to 37.11, whereas this pressure is in 992 and 1033. Since they are not in the same scale, so I have standardized the data in order to ensure that we get accurate results. Um, so first model, so that is the column transfer I have used here. So first model I have used is linear regression. So the linear regression I have given the X train and Y train data, and I have calculated the intercept and coefficient. So that basically will indicate that I have alpha is my intercept, which is 454.3, and for each of the four features that I have the four betas that are mentioned, and I have given the correct interpretation here in terms of what I understood from the linear regression. So then I have tested the output, that is prediction based on the testing data, and I have calculated the accuracies in terms of MSC, RMSC, and the R square values. So we can see that RMSC is coming as 4.5 and R square is coming as 93.16%. So then I went ahead and did the k-fold cross validation to ensure whether this is not by chance. So I have done 10-fold cross validation with R square as my scoring metric, and I have received the standard deviation across all the 10 cross folds as 0.006. So which indicates it's a good it's a good model because the accuracy is pretty good across all the models. Now, second model I tried is lasso regression. So the lasso, we understood from the lectures that it just adds up the absolute values of the betas multiplied by the alpha value, right? Alpha is a hyperparameter that we can give. So similarly, so what I have done is I have given various parameters for alpha, ranging from zero point 0.1 to 1.0. And so I have used grid search CV to run my model across all the 10 alphas that I have mentioned with a crossfold of 5. And the scoring metric is R square. So I have run that particular grid search and I have fit the data, and I have understood that the best params from my lasso model is zero point 0.1, alpha is zero point 0.1, and the best score is 92.78% R square. Now I have taken the best estimator and I have also got the coefficients and the intercept. Now I have using the best model I have received, I tested on the test data, and again I got the RMSE, MSE, and the R square values. And what I understand here is that the results are similar to what I have received as linear regression model. And what we can observe is so basically the values are almost similar. Okay. Next is about the KNN regression. So I have tried KNN regression. So KNN basically it calculates the distance from all the data points, and based on the nearest neighbors, that the k parameter that you provide, so it will try to provide which is the best suited value according to the nearest neighbors that are present for this particular data point. So similarly I have created the knn pipeline, and I have tested with the basic initially input as 20 and weights as the distance. And I have received the results as 95.34, and I have done k-fold cross validation, and I have received pretty good standard deviation across all the 10 k-folds that I have. Then I went ahead and tried for multiple other hyperparameters, like nearest neighbors as these and different weights. Instead of using distance-based weights, I can use uniform weights for all the distances across various neighbors that I have. I can use other type of metrics such as distance metrics such as Minkowski, Euclidean. I can use other distance metrics as well. Then I did the grid search and got the best model, and the best score is 95.13. And yeah, these are the various results I have. And based on this, I have predicted and I have received the R square as 95.61%. And we can see among all the three models that I have, KNN regression has done the best with R square as 95.61 and lowest RMSE of 3.61. And linear and lasso regression has given similar outputs. This is my observation. Thank you.